Last class we have seen the design of breakwater. We will continue the design. We were designing for 4 meter water depth with surge and other high tide levels giving 0.8, 4.8 meter. Maximum wave height we have calculated 0.78 times the water depth, and we have to design for significant wave height, not for the maximum wave height. See, the designing for significant wave height is like this: you have so many wave heights, we can either design for average wave height or maximum wave height, but instead we are designing for significant wave height, that is average of top 1/3 of the waves. But in ship design, floating body design, we design for h by 1 by ton. 1 by ton means top 10% of the wave, that average we take. So it depends on how you do the experiment, present the result and derive the semi empirical formula. This is the formula which is being used. This is the weight of the individual armour unit, is based on the density of the individual armour unit, and then the wave height, this is the significant wave height. Kd is the stability coefficient, depends on the type of armour units. Sr is the ratio between the unit weight of armour to unit weight of sea water. Cot theta is the slope, and we have to use 2 layers. So we have substituted and we have got 2.585 tons, but we are providing about 3 tons. When you give like this, you should find out what is the size of the stone. The size of the stone is the unit weight of the stone 3000 kg divided by the unit weight of stone to the cube root, it is coming about 1.04 meter. I am sorry, meter is not here, it is 1.04 meters, that is the size of the stone, 1 meter size of the stone. The typical size you may get 1 by 0.9 by 1.1, it is not exactly 1 by 1 by 1, it is not preferred 1 by 1 by 1 also. Then we have to see the 2 layer thickness. The number of layers is 2. Kd is a layer coefficient. Layer coefficient means when you stack one over the other, there may be some voids, some gaps. So the thickness will not be number of layers into size of the stone, and size of the stone also is not uniform, it is not 1.04 in all the directions. So to take care of that, we have a layer coefficient which is called as Kd. This also changes depending on the type of armour unit what you are using, that is the layer coefficient. This will be available in some textbooks, or there is some shore protection manual in which this layer coefficient is available. I will give this layer coefficient and stability coefficient in a table form towards the end of this lecture. So the thickness of the armour layer is 2.392, but we provide 2.5 meter thickness for the armour layer. This is the main parameter what we are designing. We are designing the weight of the armour stone, diameter of the stone, that is the size of the stone, and thickness of the armour layer. This is one of the most important design that we have to carry out for the breakwater. Next we have to find the crest width, that also depends on number of layer stones, quarry stones, layer coefficient and the crest width in meters, and B will be 2.392, but we provide 4 meter because for construction purpose when you do it on a end on method, the lorry and other has to travel, that is why we give 4 meter. This is for very small fishing harbours, whereas when you go for main port breakwater, minimum width required is about 8 meters because we need 2 lane highway. The fisheries harbour, the water depth will be restricted to about 4-5 meters, whereas main ports the breakwater will go up to 10 meter water depth. So though 4 meter width is sufficient up to about 4 to 5 meter water depth, this is access, so you have to increase it for 2 lane traffic. So we were discussing that there are different layers. One is the armour layer, then we have the underlayer, then core layer, then bedding layer. We will see how to design the core layer. The core layer, this supports the protective armour cover and any other underlayer, that is this is what is used as a foundation for the other layers. The other important thing is it prevents sediments passing through the breakwater. So this is important. So, whenever there is a sediment which is suspended in the water, that should not go through the breakwater. What happens if it goes through? It will go inside and settle and you have to dredge, but it will go through the armour, because armour has lot of voids. It may go through underlayer, that also has voids, whereas core layer you make it in such a way that the voids are minimum and it will not go through this. You cannot make 100% void free because we are stacking. The size of the stone in core would be W by 100. This W is the weight of the armour unit, whatever is the weight of the armour unit divided by 100, and 3000 kg is the weight of the armour unit. 3000 by 100 is 30, but we provide 50 to 125 kg, slightly higher values we can provide, but this formula will be applicable for bigger armour size stones, not for smaller armour size stones. So, when you do this civil engineering practice, we may not exactly adopt the formula, because the formula is applicable for a wide range of water depth. The same formula, Hudson's formula, is used whether it is 4 meter water depth or 10 meter water depth or 15 meter water depth. So, but towards the end I will give a range of this core layer stone. The bedding layer is between the core layer and the soil seabed, that is the soil type. Depending on the soil type in the seabed, you have to provide the bedding layer. The purpose of the bedding layer is to act as a foundation to support the entire structure, and we provide the stones of size 1 to 50 kg and the thickness is typically about 150 millimeters. You cannot put it directly your core stone on top of the seabed, because core stone size is bigger, 50 to 125 kg. So, when you put it, it will get into the seabed and it may get settlement also, and the proper distribution of pressure will not be there. For that reason we put this. Sometimes below the bedding layer we use geotextile fabric. If the seabed is clayey soil, we put a geotextile fabric. The purpose of the geotextile fabric is like a filter, like a coffee filter. What happens in a coffee filter? You put a coffee powder and water pours in, with the coffee decoction it comes down. Same thing only the geotextile filter does. It allows the water to go either from the seabed to the this bedding layer or from the bedding layer to the seabed, but what it prevents is, it prevents the clay particle to get into the bedding layer. That results in cover, that should be avoided. We do not want the clay particle to get into the foundation layer or vice versa, that is why we put a bedding layer. Geotextile fabric is like Netlon mesh and things like that, only the aperture size is less than 75 microns. Then we have another important parameter that is called as the toe design. I was repeatedly telling most of the failure is because of the failure of toe mount. There are two things that are to be designed, one is the width, another is the height. The width of the toe mount based on two criteria. This is the maximum of twice the wave height or 0.4 times water depth. Use two consideration, how much is twice the wave height and how much is 0.4 times the water depth. Water depth is already given 4.8, wave height based on the water depth we arrived as 2.34 meters. So, twice the wave height is 4.68 meters, 0.4 times water depth is 1.92. You take the maximum of this, so you take about 5 meter as the width of the toe mount. Typically 50% of the width is taken as height of the toe mount. It may look a little bit odd to you, we are giving like this, but this is the practice, because some of the parameters what we are using is based on so many years of experience and design. Okay, we know what factors is critical for the toe mount design, but we give some empirical relations. So, this is the final structure. I may ask this question in your we will be conducting two quizzes. One of the quiz I may ask, if this is a problem which is given, you have to calculate whatever has been given so far. I may change the water depth, based on that your wave height will change, your weight of the stone will change. So now I will tell you what from the bottom. Here we may put a geotextile filter if the seabed consists of clay, but even if it is sand we may put a geotextile filter. Here it is not shown because with the advancement in technology recently we have started using the geotextile filter. Once you put a geotextile filter, the whole unit acts as a single piece, otherwise geotextile filter is a continuous thing. It is available in 3 meter width, but when you are laying it you stitch 3 meter by about 200 meter may be available in a roll, but if you are putting 3 meter in this direction or in the other direction you overlap and stitch it and lay it, that means you have a continuous layer here, whereas the foundation is discontinuous. So the providing the continuous layer makes it to act monolithically and it also prevents the scour to take place. Then we have the bedding layer given as 1 kg to 50 kg stone. Then we have the toe mount 150 kg to 500 kg stone. The width we have designed as 5 meters, the depth we have designed as 2.5 meters. The bed level is minus 4.0. This is marked as 3.5. I think they have given 500 mm, but originally we written about 150. Maybe this they have increased it further, but we can put 150 also. Then the core layer is 1 kg to 150 kg stones. Why this wide variation of 1 kg to 150 kg is the particle size will be different. 150 kg will have a void in which let us say 100 kg will get into it, 100 kg will have a void in which 50 kg will go, 50 kg will have a void in which 20 kg will go, 20 kg will have a void in which 1 kg will go. Concrete is also like that. Concrete consists of cement, sand and coarse aggregate. Coarse aggregate is 40 mm, in that you put the sand, the particle size is very small in microns, that will fill up, then in that you put the cement, that will fill up the void. So here also the core is like that, so that the permeability in the core is negligible. It will not, if it is the seaside, if the water is coming, sediments are there, it will not get penetrate through this. Larger width is there, it may penetrate but it will not go to the other side, and the wave disturbance outside also will not percolate through this, that is another thing. Then this is the armour layer. The thickness we have designed it as 2.5 meters, sorry 2 meter I have written, I think there is a mistake in this, I think 2.5 meter, and the stone size is given as 3000 kg. We have to put 2 layers for this. This is a typical cross section of breakwater. Any doubts in this? One of the major design what we have now done, if we take a typical port today it is being developed, it will be developed for about 10 million tons, because the viability will not be there if you do it for a greenfield port less than 10 million tons. To develop 1 million tons of cargo, to develop a port to handle 1 million tons, it will cost 100 crores. This is some block cost estimates. So for 10 million tons it will be 1000 crores. Out of this 1000 crores, breakwater will be about 30%, 1/3 cost will go to breakwater, 1/3 cost will go to berthing structures, the other 1/3 cost will go to dredging. These are typically the 3 components. The other 10% will go for other miscellaneous structures, navigation light, stockyard area, godowns, things like that. Is it clear? If you want to develop a port, 1,25,000 crore is the estimate that we are going to build in the another 10 years, that is what we are going to spend on this. So if you are specializing, you have great opportunity in India. So 10 million tons means it will be 1000 crores, breakwater is 300 crores. It is a very simple structure. You have seen how the various parameters are designed, but we have to do a physical model test to confirm, but this is at the undergraduate level how you design. Now the coming slides I will be giving you what are all the other parameters which are to be critically examined before finalizing the breakwater design. This is a textbook design what you can learn but if you want to do a professional design you should know the parameters what are there in the other slides. So this figure you please draw and write down all these parameters. I will ask how will you determine the weight of core, underlayer, armour layers. It's only a question, you do not have to do any calculation, but this figure is important. So now we will see the first layer, that is the armour layer. Armour layer is given here W. This W is calculated from Hudson's formula. Then we have this underlayer, that is W by 10, underlayer 1. Then we have this layer, this is W by 200. Then we have this layer, that is given by W by 4000. So these are the various things. W is the primary cover layer, that is the armour layer. W by 10 is used both for the toe berm as well as for the second underlayer. I am sorry, toe berm and first underlayer is W by 10. I think there is this is the, I am sorry, this is your first underlayer and this is your toe berm. This is a foundation for the toe berm and this is the second underlayer, that is W by 200. Then W by 4000 is core and bedding layer. The parameters that are governing is the wave height, weight of individual armour layer, and R is the average layer thickness. In the earlier design I have given this width based on some other, there are various formulas available, Hudson's formula, Vandermeer's formula for armour layer design. It is not one formula which is available in the industry practice. If we want to calculate W, W is based on Hudson's formula, but we have another formula called as Vandermeer formula. I am not teaching you in this class. Similarly, for calculating the toe beam width and depth I have given some parameter, but it also depends on the average layer thickness. Typically the thickness of any layer is twice the thickness of armour units. So the average layer thickness of armour unit or bedding layer or toe beam layer, if this is 1.5 meter, you have to provide twice that. To make it very simple, suppose at this second underlayer, let us say that we are using 75 mm metal size, then what you do is twice 75 mm is 150 mm. So the layer thickness to be used is 150 mm, since we are using 2 layers. So minimum thickness is 150, you can provide more also. This point is clear to you. What we are using is, you know the thickness of the stone that is used, and there are some coefficients to get the average single layer thickness. You multiply twice, that will give you the thickness of toe beam. Then the width is about 3 times R, that is for the toe beam, right. Like this you have to calculate. So here this formula is for very big water depth. The other formula what I have given is also correct only, that is for 4 meter. This formula is correct only because this is for larger water depth, we have to go in for W by 4000. Sometimes they give a range W by 1000 to W by 4000. It is not normally we cannot use one size. Obviously if the core layer has to be impermeable, you have to use wide range. So they may use W by 100 to W by 4000 also. So here what they have given is minus 1.3 H, that means what they do is, this is your seabed, there are different concepts. Suppose this is your seabed, they excavate below the seabed for 1.3 times the wave height and then fill this with foundation stone. Foundation means in civil engineering practice it is below the seabed. So what this slide shows is you excavate below the seabed, how much you have to excavate? 1.3 times the wave height. Sometimes it is very difficult to do 1.3 wave height if the wave height is very large, but for major breakwaters if the soil is very bad they may excavate even up to 3 to 4 meters. This point is clear, no? You have a seabed, below seabed excavate 3 to 4 meters, then start filling the core as well as the foundation stone, not put it directly on the seabed. But if the seabed is very good, it is rocky strata, or if it is a very dense sand, you can directly put it on the seabed also, you do not have to excavate. See, this civil engineering design is mostly site specific. Suppose you are designing a building in Chennai and same loads, that is the configuration, dead load, live load, everything is same. Suppose you want to build the same thing, let us say in Guwahati, what you have built in IIT Madras, you want to build in IIT Guwahati, can it be used? Yes or no? You have to answer. No means why we cannot use? What are the factors you have to consider if it is in Guwahati, which will govern the design? Somebody said soil, soil is one consideration, what are the other things? Climate. Earthquake, that is the main parameter. Guwahati in seismic zone 5, Chennai is, I think it is in 3, so the force will be enormous. Similarly wind also will be different, so we cannot use. Same way here also, depending on the seabed the foundation requirement will be different. Now we will go some more details about this underlayer. Single or many means you can have single underlayer or 2 underlayers or 3 underlayers. Typically 2 underlayers are used. Underlayers are this one, this color and this color, these are the 2 underlayers. Purpose is to support armour units. Suppose you want to put about armour unit weight is, let us say, about 12 tons. 12 tons if you want to support on the seabed, it is not possible. So you go on build so that you can be to a considerable height with gradually increasing size, so that you can use the armour stone, place the armour stone. That is the purpose of armour, this underlayers. The design principle is unit should not penetrate through the voids of armour, that is the thing. Suppose there is a voids in the armour, this should not penetrate through that. That means the weight distribution, see when you do the breakwater construction there are 2 issues involved in this. One is transportation of this rock materials from the quarry, another is placement. So when you transport armour layer separately, underlayer separately and then core layer separately. You segregate in the source itself, do not bring from the quarry all size and try to segregate at the port construction site. When you transport itself, you transport giving different batch names and bring it to the site and stack it separately. Do not bring it and dump it into the breakwater, there will be logistics problem. So you will be constructing, the lorry may not come and you will stop. You can never stop the breakwater construction. If you stop the breakwater construction without the head, I said there is a head for the breakwater, then it will get washed away in a storm. Suppose there is a 9 months period only available, for 3 months you are stopping, you have to stop because you may not work in a very bad weather condition, you have to provide temporary head where you are stopping, otherwise whatever you have built to get washed away. It has happened in some of the projects also where we have executed. Normally cyclone starts in Kerala, northeast monsoon. When does it start? I am sorry, southwest monsoon. Which month it starts? How many are you from Kerala? Which month you will have the monsoon? I am not sure, June, I think it is in May, sometime in May it starts, maybe I have to check, but 1 month ahead of the monsoon, scheduled monsoon, in 1 year it has started. If it is June, it has come in May 4th. Then one breakwater what we are building in Kanyakumari, we are building for 250 meter, 100 meter get washed away because we are not expecting the monsoon to come 1 month ahead, that is the problem. Here we have given D15 size of the armour unit should be less than 5 times D85 size of the underlayer. What is D15 and D85? Civil engineering students, not effective diameter. How many of you have done sieve analysis in the laboratory, civil engineering? Huh? What is sieve analysis? What is sieve analysis? You have physically done or you ask somebody else to do? What is sieve analysis? Now how did you do it? You really sieved the different particle sizes? Sieve is nothing but a jalladai. Jalladai, what is in? See, we use that wheat flour and maida flour and all, no, earlier days. In the house we have that round thing with a filter fabric. House ladies used to do that to segregate certain impurities or sometimes some insects also. Same thing only here, we have sieves of different size. Whatever you are getting from the sample, you do the sieving in different filter size, filter aperture size, then direct. Normally when you give the particle size, we use D50. D50 size means if we have the sieve of that aperture size, if we put the soil particle, 50% will be retained and 50% will go below, that is called as D50 size. Okay. D15 means 15% will go out, 85% will be retained. D85% means 85% will be going out. So we have to have D15 to 5 D85. The point is clear now, 50-50 is clear to you. 50 means if you have a sieve of aperture size D50 and if you pour the sand particle, 50% will be retained and 50% will go through. D15 means 15% will go through, 85% will be retained. So this is what we have to do. We have given some general guidelines, but there is a basis also for this, that is what I am explaining this to you. If you do a major project, you have to calculate what is the armour size, that you cannot do it in a sieve, you have to do separately, it is not possible to get this. So core layer, this supports armour and underlayers, this prevent penetration of waves and sediments is the purpose. Design principle, unit should not penetrate through voids of overlaid layer. To avoid sediment pass through, the range should be W by 100 to W by 4000, this is the range. I am not purposely telling all the ranges in the beginning itself, because you will get confused, what is this range, why it should be done. I have put this at the end of the class. Slowly I am trying to bring this level of this breakwater design on a scientific basis. If I tell in the beginning, mostly you will get confused, why there should be a range of stone size, right. We need a range of stone size, it is preferable. The toe beam, this stability against cover and sliding. Cover means if you go to the beach and stand in the water, what happens below your feet? It gets covered away around your place. Same way if you build a breakwater, what will happen? It will get covered away. So to prevent this cover, we need this toe beam. And sliding we will discuss later, it is having some force calculation. The whole breakwater stone what you are putting in the armour layer, if the toe beam is not there, it will go down, for that only we need this. This distribution is between W by 10 to W by 15, it is not uniform. So if you see the core layer, the distribution is wide, W by 10 to W by 4000, whereas if you see here it is W by 10 to W by 15. Even armour layer there is some variation. If you have calculated armour layer is W, armour unit weight, you may not put W, you may put 0.75 to 1.25 times W, you may not put the single size stone, it is not possible. The filter layer, foundation for the entire upper superstructure, this is the one, and also prevent settlement of rubbles into seabed. If you have the settlement of rubbles, that is the core layer stones into seabed, that will also accelerate corrosion, I am sorry, cover. A design principle is this has to uniformly distribute the entire weight of the groin or breakwater into the seabed by avoiding the settlement. So what we are trying to do is we are trying to distribute the total weight of the breakwater unit for a larger and wider area. For that only we have to use the foundation. So if the soil has a bearing capacity means how much load it can take. Suppose the total weight is x and the bearing capacity is usually in kilonewton per meter square, that is y, your distribution should be x by y, x is kilonewton, that is the weight, total weight for unit width, and the bearing capacity is kilonewton per meter square. So whatever you get will be the width, because you are taking 1 meter along the length of the breakwater. Suppose there is a breakwater, along the length of the breakwater you take 1 meter, then calculate the total weight, that is x. Bearing capacity based on soil mechanics testing and other things, you get it as y, x by y will give you the width of the breakwater. So this will be d by 15 of upper layer should be less than d by 85 of lower layer. This distribution also weight W by 2000 to W by 6000, but minimum size is restricted to 100 millimeter. This there is a very good reason not to put very small size stones. You are putting it in the seabed in open sea condition. If you put very small size, where you are putting it won't be there. If you are putting at Gajendra circle, it may go to Kaveri hostel. So if you even here when you put a filter layer, only about 50% or 60% will be at the place where you wanted to put, even if you put 100 mm, otherwise it will get dragged away to some other place. If you make a trench, that is why they make a trench for foundation, then you can dump it in that. That is why sometimes they prefer to have a trench of at least 1 meter and put the foundation layer on that. If you make a trench and if you drop it, it will not go elsewhere. So this is DN50 is the nominal diameter, but you please understand this DN50, normally we use this DN50 is the nominal diameter when you talk about any different layers. The additional design components are crest elevation. So when there is a storm surge and there is a run up, I will explain later about this, your top of the breakwater should be above this. The crest width depends on construction requirements as well as the overtopping. The thickness and of armour and underlayers, this depends on the size of the stones and number of layers. So these are the design components, out of which the top two is very important, the top of the crest. So if you see the order of failure reasons, the first one is the toe, the second one is the crest elevation. If you have not provided the crest elevation properly, then also it will fail. Sometimes the crest elevation is not based on significant wave height, it is based on maximum wave height, and again based on return period. Whenever I talked about the significant wave height or maximum wave height, this is based on depth dependent. Suppose it is dependent on steepness, what you do is you calculate the significant wave height, that will be different for different return periods. Suppose you take a 25 year as the design period, return period, if you get the significant wave height as 5 meters, if you increase it to 100 meters as the return period, it will go to 6 meter or 6.5 meter. You understood, no? If a return period is 25, you are extrapolating, you get about 5 meter as the significant wave height. Suppose you make it 100 meter, it may go to 6 meters, 100 years, If we take it to 1000 years it may go to 6.5 meters. Based on the return period only you have to design what is the significant wave height. It is not based on only the wave climate at a particular location, based on return periods. What is the return period of tsunami? Tsunami return period, if you want to take, it is once in 500 years. We had a tsunami recently 2002 or so, 2004, then the previous tsunami was about 500 years back not recently. Some of the earthquakes the return period may be about not return period, in 100 year you may get an earthquake, in 1000 year you will get much higher earthquake. So if you take Andaman Nicobar Island 100 year return period, your intensity may be about in Richter scale 7 or 8. If we take 1000 year it may be nearly 9.5, 9.8. Return period is very important. So these are the different types of armour units. This is the block, crude, acropod. I have shown that in the last one of the meetings, dolas, CB, cube, crude cube, tetrapod. This is most commonly used in India, this tetrapod, and acropod also we have used. The difference between acropod and other things here, acropod is single layer, we do not have to provide double layer, but placement is important. Acropod, we have to use a GPS and position the acropod. This tetrapod and other armour units are randomly placed, you can just place it anywhere. So in location where large size natural rocks are not available, artificial armour blocks are adopted. So we will see this table is not simple table, it is but I will explain what it has. This first column it gives what is the type of armour units, whether it is a quarry stone, whether it is a tetrapod, whether it is a dolas, and the placement is random placement or special placement. The structure trunk, structure head, you know what is trunk and head, I have shown the figure. Head is at the nose of the breakwater, trunk is at any section. You have this KD coefficient, trunk there is a KD coefficient, head there is a KD coefficient, and this KD coefficient is very strongly dependent on slope of the breakwater. The slope is cot theta, it can vary from 1.5 to 5 for a quarry stone, but typically it is between 1.5 to 3, that is the slope of the breakwater what you are using. And we have two types of waves, breaking waves and non-breaking waves. When you say a particular wave, when it reaches a water depth where the water depth cannot sustain that wave, it breaks. Sometimes the waves break on the breakwater itself. Suppose the maximum wave height that is coming at a particular location with 100 year return period is only 6 meters. In 10 meter water depth it may not break, that means it is non-breaking waves. Is it clear to you? Suppose I am designing a breakwater, breakwater is designed for a water depth varying from 0 meter to 10 meter. For 100 year return period the significant wave height is 6 meters. 6 meter wave when it will break, 6 meter wave will break, h by d is equal to 0.78. So 6 by 0.78, that water depth only it will break, maybe 8 meter it will break, 10 meter it will not break. If you are using the same unit, let us say this tetrapod you are using, for a non-breaking wave the stability coefficient is higher, stability coefficient is coming in the denominator, but if it is a breaking wave it is less, that means the stone weight will be more if it is a breaking wave, and if it is less it will be a non-breaking wave, and in a head it will be much less because we are getting the waves from all the directions. Point is clear, no? Stability coefficient is not constant, though the formula is simple, stability coefficient depends on the slope, it depends on the whether it is a head or trunk, or it depends on the breaking or non breaking waves, it also depends on type. Suppose I am using 8 for tetrapod, for stone I may be using angular stone only half of that 4, if it is breaking we will use only half of that 2. Why we cannot give a definite value of Kd? This is because interlocking between armour units, interlocking between layers, function or type of armour unit, type of structure, slope and extent of armour layer, wave impact characteristics, wave height. I have not told wave period also is a function, wave height to water depth ratio, degree of acceptable damage to armour layer. So this we will continue in the next class.